Answers to assignment questions. Question 129. This is a large tank of soup. First, the specific heat capacity of soup is similar to water, which is high. And then this is a large tank of soup. That means the mass of soup is also large. It will make the heat capacity of soup very high. When noodles are added, the temperature drop of the soup would be very small. Question 130. The diagram shows the formation of sea breeze in daytime. During daytime, the temperature of the land rises, and the land is hotter than the sea. The air above the land rises and forms clouds. As the sea is cooler than the land, the clouds becomes cold when it is over the sea. The cooler air above the sea sinks, and the sinking air spreads along the sea and becomes sea breeze. Question 131. The solar line shows the change of air temperature in Hong Kong. For the change of sea temperature, which has a high specific heat capacity, the temperature change would be smaller and more gentle. And please note that the sea temperature will be lower than the air temperature when it is hot, and the sea temperature will be higher than the air temperature when it is cold. Question 132. Napa is a city without water around, and so its temperature change would be even larger than the air temperature change. You can see the dotted line has a lower temperature when it is cold. It has a higher temperature than air temperature when it is hot. So the land temperature changes more sharply and quickly than air temperature. Additional question. Question 1. What the question says. The resistance of pendulum wire changes with temperature. At 0 degrees Celsius, the resistance is 3 ohms. And at 100 degrees Celsius, the resistance becomes 5 ohms. In part A, it asks you the temperature when the resistance is 4 ohms. To calculate this answer, 50 degrees Celsius, you should apply the equation in your book. For part B, you have to find the resistance when the temperature is 60 degrees Celsius. Similarly, you use the same formula. Question 2. In this question, there is an aluminum block, rather hot. It is put into cold water. You have to find the final temperature. We assume there's no heat loss to the surroundings, so that the heat gained by the water will be the same as the heat loss by the metal. You set up the equation, and then you may find the final common temperature, 26.8 degrees Celsius. Question 3. You are asked to find the energy to increase the temperature of an aluminum block from 20 degrees Celsius to 100 degrees Celsius. Easy. Question 4. In this question, there is an immersion heater which is used to heat up some water. In part A, you are asked to find the energy supplied. You can only find the energy gained by the water, and you assume that the energy supplied is exactly the same as the energy gained. In part B, then you may use the energy gained by the water to find the power of the heater. However, you may know there may be energy loss, and this is one possible error of the above calculations. Question 5. Similar to the last question, you are asked to find the energy supply and energy gain. However, you are given the joule meter readings before and after heating. From the joule meter readings, you can find the energy supplied to the heater, and in this way you may find the specific heat capacity of water. This is found to be a little bit larger than 4,200 joule per degree Celsius per kilogram. Why? because not all the energy, 6004 joules, are absorbed by water, as we assumed in part B. So, the calculated specific heat capacity is a little bit larger than the standard value. Do not miss the next 6 minutes video about Section 4, Heat Transfer. Chapter 4, Heat Transfer by Conduction. There are 3 types of heat transfer processes: conduction, convection, and radiation. In this chapter, we will talk about conduction. Conduction is due to energy exchange between the hot and cold area through particle collisions from the hot end to the cold end. Different materials conduct heat differently. We say they have different conductivity. Some substances conduct heat better. We call them heat conductors. Some conduct heat poorer. We call them heat insulators. And let's see how the following experiments compare the heat conductivity of different materials.
Now we will investigate what kind of solid conducts heat faster. Put a wooden rod, an iron rod, a copper rod, and a glass rod into a beaker of hot water. Feel the ends of the rods to find out which rod gets hot first. Which material conducts heat the fastest?
Use wax to stick drawing pins at one end of the rocks. Hit the other end of the rocks and observe which drawing pin falls first.
The range of heat conductivity is large. Silver, copper, and aluminium, they are very good heat conductors, and they are all metals. While wood, foam, and air, they are very good heat insulators. They are all non-metals. To many people's surprise, water is not a good heat conductor. It does not conduct heat very well. Let's see the following experiment. It will show you how poor water conducts heat.
Now we will study the conduction of heat in water. Use a piece of wire gauze to keep some ice underwater at the bottom of a boiling tube. Gently heat the top part of water and observe the ice. What can you say about the temperature difference between ends of the boiling tube?
4.2. Microscopic explanation of heat conduction. As we said at the beginning, conduction is due to energy exchange from the hot end to the cold end through particle collisions. And now let's look at the details. When one end of the rod is heated, the temperature becomes higher. In fact, the average kinetic energy of the particles becomes higher. So these particles vibrate faster, and these faster moving particles collide with their laboring slower particles and transfer their kinetic energy to them. In this way, energy is transferred to the cold end through particle collisions. So when heat is conducted from the hot end to the cold end, microscopically, there are particle collisions that transfer kinetic energy of particles from the hot end to the cold end. And why metals may conduct heat even better? Because metals have free electrons. They carry the kinetic energy, and they even travel directly from the hot end to the cold end, carrying with them their kinetic energy. 4.3. Examples of conduction and insulation. Birds and mammals are warm-blooded. It is necessary to reduce the heat loss to the surroundings. Birds have feather. Mammals have hair. Both of them trap a layer of air over their body, which can reduce the heat loss to the surroundings by conduction. Warm-blooded animals living in the cold climate, they even have fur and specialized feather to trap a even thicker layer of air to further reduce the heat loss in the very cold weather condition. On the other hand, we human beings, we put on clothes to trap a layer of air over our body to reduce heat loss to the surroundings. Cooking utensils, on the other hand, they have to conduct heat faster. However, they also have handles which are made of insulators. The body of cooking utensils are made of metals, and some even have an aluminum layer which conducts heat better than other metals. Some expensive cooking utensils have an aluminum layer in the middle to conduct heat to all parts of the pot, while the stainless steel outside layer provides strength and shiny outlook of the pot.